boiling for over 300 years. But how? Why is it boiling? And can anything live in such high temperatures? Let's find out. This is an aerial shot of the Amazon rainforest. Now, let's zoom right into the center of the screen here. Right there, you see those white patches. That's steam rising from the river. And then look at all the bubbles in the water. That's because the water is boiling. Boiling water gives off steam. The steam is why there's so much humidity in the Amazon rainforest. The reason why this river is boiling is still a mystery. But what we do know is that the water here reaches up to 91 degrees Celsius, or 196 degrees Fahrenheit. At those temperatures, most life would be very scarce. But even though this river has been boiling for over 300 years, scientists are still confused about how it's even possible. Now, we'll pan across to the edge of the river. There, we will see some scientists by the river bank. They have come here to try and solve the mystery of the boiling river. Just imagine if one of these scientists accidentally fell into the river. They'd probably be cooked like an egg. These scientists are taking samples of the river water to try and figure out what's causing the river to boil. One of them is holding a device to measure the temperature of the water. So far, they have found out that the river water is not acidic or basic. It's neutral. If we go deeper into the rainforest, we'll find many different types of plants and animals. But remember, this is by the boiling river. So we won't find much life here because it's just too hot. The plants and animals that do live here have special adaptations to survive in the heat. As we go further down the river, we'll find even more bubbles. This is because the water is getting hotter. Eventually, the water will start boiling. Here, we can see that some of the water has turned into steam. Many people think that this river might have been caused by a volcano. Perhaps there's a volcano under the rainforest, and the heat from it is making the river boil. Well, there are plenty of volcanoes in South America, but none of them are near here. Another idea was that maybe there's natural gas under the riverbed. Maybe the gas is leaking out of the ground and making the river boil. Well, that might explain the steam, but it wouldn't explain the bubbles in the water. Also, if we were to take a sample of the gas and bring it back to base, we will be able to tell exactly what it is. They've done this, and they have found out that it's not natural gas. We now switch to a satellite view. We can see the entire Amazon rainforest here, so let's zoom into the river. Remember, the blue parts are where the river is boiling. It looks like a giant snake. And here's the solution to the mystery. Deep inside the rainforest, deep underground, there is a lot of geothermal activity. The Earth's core is extremely hot. The heat from the Earth's core radiates outwards. As it radiates outwards, the heat eventually reaches the rainforest floor. Here, the heat is released into the atmosphere as steam. But how does that explain the bubbles in the water? That's because the heat is also conducted through the rocks and soil into the river. The heat is transferred from the solid rock to the liquid water. If the heat is being transferred into the river, then that means that the water must be boiling. But wait a second. Doesn't water freeze when it comes into contact with ice? How is it that the water isn't freezing? That's because of something called the latent heat of vaporization. Essentially, when water boils, it needs to absorb energy before it can turn into steam. That means that the boiling water will always be at 100 degrees Celsius, or 212 degrees Fahrenheit. It doesn't matter how cold it is outside, it will still boil. However, in this case, the river isn't just boiling at 100 degrees Celsius. It's actually boiling at 91 degrees Celsius, which means that it hasn't reached its latent heat of vaporization yet. It needs a little bit more heat. That extra bit of heat is coming from the geothermal activity below ground. Now, let's do a quick recap. We have learned that the river is boiling due to geothermal activity below the ground. The heat is being transferred into the river, causing it to boil. However, the river is still not boiling at 100 degrees Celsius. So that means that the heat is being used up to increase the temperature of the water. But if the heat is being used up, then why doesn't the river ever stop boiling? That's because of something called thermal equilibrium. Thermal equilibrium is basically where two objects are at the same temperature. In this case, the boiling river and the air above it. Right now, they are at the same temperature, so the steam is rising at the same rate that it's being created. But what happens if the river cools down? If the river cools down, then that means that it will reach thermal equilibrium with the colder air. When that happens, the steam will rise faster than it's being created, causing the river to cool down even more. Eventually, the river will reach a point where it's not boiling anymore. Now, let's go back to our scientists by the river. They're examining some rocks that they took from the riverbed. By analyzing the rocks, they should be able to get an approximate age of the rocks. The older the rocks are, the longer that the river has been boiling. By doing some tests in the lab, they have found out that the rocks are around 570 million years old. This means that the river has been boiling for at least 570 million years. But remember, this is just an approximation. The scientists also want to test the water to see if any organisms are living in the river. Perhaps there are some extremophile bacteria that can live in such high temperatures. To collect a sample of the water, they lower a container into the river. Back at base, the scientists are examining the water under a microscope. So far, they haven't seen anything. They are starting to lose hope. But then, wow, they just saw something move. They can't believe their eyes. They have found some microorganisms living in the boiling river. These microorganisms are called thermoacidophiles. These bacteria are capable of living in high temperatures and acidic environments. But how are they surviving in a neutral boiling river? Well, they seem to be surviving by consuming sulfur. It seems like these bacteria have a special adaptation that allows them to survive in the river. For a long time, scientists thought that life couldn't possibly exist in such high temperatures. But these bacteria proved them wrong. Even though the river has been boiling for hundreds of millions of years, there are still microorganisms living in it. The reason why there aren't any larger animals in the river is because there isn't much nutrition in the water. Larger animals need more nutrition than what the river can provide. So now we know how the river is boiling. We know that it's due to geothermal activity below the ground. And we also know that there are some thermoacidophile bacteria living in the river. But how did the river even form in the first place? Well, rivers are formed when there's a higher elevation somewhere. The water will flow from the higher elevation to a lower elevation. It seems like there must have been some sort of event that caused the land to raise up. Well, look at the edge of the rainforest. That's raised land. Over millions of years, the water has flowed over there and formed a lake. Some of the water has leaked under the raised land and has formed an underground river. But how did the raised land form? Well, we know that there's geothermal activity below the ground, and that's what's causing the boiling river. So perhaps there's so much geothermal activity that is actually pushing the land upwards. There are many interesting theories about the origin of the river. One of them is that there's a giant bubble of magma underneath the rainforest. That bubble is pushing the land upwards and forming a raised area. Over time, the bubble gets bigger and bigger. Eventually, the pressure becomes too much and the bubble bursts. When it bursts, it releases all of its energy. This could cause the surrounding land to collapse. When the land collapses, it forms a hole. The water from the nearby lake flows into the hole and forms a river. This river may have been formed due to a giant bubble of magma. But what keeps it boiling today? Well, remember what we said about thermal equilibrium earlier? Well, if there are no large bodies of cold water nearby, then the river won't cool down. That's because the river is constantly being heated by the geothermal activity below the ground. The heat from the geothermal activity causes the river to boil. The reason why the river doesn't freeze is because the boiling river is always hotter than the freezing point of water. This is why the river will continue to boil for millions more years. But what about those microorganisms? They must be freezing at night, right? Well, you might be thinking that the boiling river is always hot, but that's not true. The river follows the same day-night cycle that the rest of the world follows. That means that the river will freeze at night when it's cold outside. But during the day, the river thaws and the bacteria can become active again. I really hope you enjoyed watching this video as much as I did making it. If you did, please leave a like. Thank you so much for watching, and I'll see you next time.